Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 10.3, solving quadratic equations by graphing. Okay, so a quadratic equation is an equation that can be written in the standard form of y equals ax squared plus bx plus c, where a is not equal to 0. We have used factoring techniques to solve these types of equations already. So we've solved them when we thought that y was 0. Okay, so there's our function. Okay, today we're going to use graphing. So solve the quadratic equation x squared minus 6x plus 5 equals 0. So solve by factoring. So we've done this before. Okay, so we say what are two things that multiply to 5 and add to negative 6? And those are going to be negative 1 and negative 5. And since it had a leading coefficient of 1, we could factor this into x minus 1, x minus 5. No box needed. And then solve those separately to get 1 or 5. All right. To do this by graphing, we do all the same stuff we did. We find the axis of symmetry. Okay, so our axis of symmetry is x equals negative b over 2a. So that's negative of negative 6 over 2 times 1. This gives us 3. Okay, and that's why our graph has an axis of symmetry of 3. And then we find the vertex by plugging 3 back in. So when I plug 3 back into my formula, I get negative 4. And then we plug some other points. So maybe I plug in 2, which will give me negative 3. And maybe I plug in 1, which would give me 0. Now, you say, well, we're trying to solve this. Well, the answers for solving are the place where our parabola crosses the x-axis. Okay? Because that tells us what x would give us a y value of 0. So we're guessing what x's give us a y value of 0, and those are going to be the place where it crosses the x-axis, and it crosses at 5 and at 1. Okay? So to solve a quadratic equation by graphing, we just need to graph the function and find the place where it crosses the x-axis. All right, so solve the equation x squared minus 2x equals 3 by graphing. Be sure to check your solutions. So this is going to be x squared minus 2x minus 3 equals 0. Okay, and we're going to graph it. So we say, all right, axis of symmetry first, negative b over 2a. So that's negative 2 over 2 times 1, which is 1. Okay, so this is our axis of symmetry. So at 1, we put a dotted line. All right, our vertex is going to be plug 1 back into our formula. So y equals 1 squared, 2 times 1 minus 3. So 1 squared minus 2. So 1 minus 2 is negative 1. Minus 3 gives me negative 4. So my vertex is 1, negative 4. So at 1, we go down 1, 2, 3, 4. All right, now this parabola definitely opens upward. So we're going to plot some points until we find the place where it crosses the x-axis. Now, I will always give you ones that cross at whole numbers, just to make it a little bit easier for you. Okay, so we have 1, negative 4. We'll go ahead and try 0. So 0 is our y-intercept, and we know our y-intercept is going to be negative 3. So 0, negative 3. Okay, but we're looking for the x-intercept, so we got to keep going. So we'll try negative 1. We plug negative 1 into our formula for x. So that's negative 1 squared minus 2 times negative 1 minus 3. So that's 1 plus 2, which is 3, and 3 minus 3 makes 0. So negative 1 gives me 0. And that means over here I can move it to this side. And now I have my parabola crossing over the x-axis. So I'll stop there because that's all we need to find. And our answers are going to be, where did it cross here? Well, that's at 3. And where did it cross here? This is at negative 1. So solve this by graphing. Sure, here's our answers. X equals 3 or x equals negative 1. All right, let's flip it over and try a couple more. Okay, number 2. Solve the equation negative x squared plus 2x equals 1 by graphing. So once again, we're going to solve or graph this function, negative x squared plus 2x, and then we need to move the 1 over so that it's equal to 0. Okay, and so we'll do our graphing here. axis of symmetry first. Axis of symmetry's formula is x equals negative b over 2a. So that's negative 2 over 2 times negative 1. Negative 2 over negative 2 is 1. So our axis of symmetry is at 1. Okay, then we need to find our vertex. So the vertex is going to be at 1, and whatever we get when we plug 1 back into our formula. So 1 comma something. So we're going to say y equals negative of 1 squared plus 2 times 1 minus 1. So that's negative 1 plus 2 minus 1. This makes 0. So 1, 0 is my vertex. And then this graph opens downward because the a value is negative. Okay. And we're going to have a y-intercept of negative 1. So I'll plot one other point. And that's enough for me to know my answer here, because all we're looking for is where does this parabola cross the x-axis? Well, where did it cross the x-axis? It crossed at x equal to 1. So our answer here is x equal to 1. We have solved it. This time we only got one solution. So a parabola could cross the x-axis twice. We get 2 solutions. A parabola could cross the x-axis only once. Then we would get 1 solution. And let's see what happens in our last one here. So we're trying to solve this equation. We got to move the 4x over so we get set it equal to 0. Okay, so we're going to do that by graphing this function, x squared minus 4x plus 7. All right, so one more time, axis of symmetry. That's x equals negative b over 2 times a. This is negative negative 4 over 2 times 1. So 4 over 2 is 2. So our axis of symmetry is at 2. Okay. And then we're going to plug that back in to get our vertex. So our vertex is going to be, let's see, y equals 2 squared minus 4 times 2 plus 7. So 4 minus 8 is negative 4. Plus 7 is 3. So our vertex is 2, 3. So 2 over 3 up. And then this parabola is going to open upwards because our a value is positive. So I'm not even going to find any other points, although we could easily plot our y-intercept at 7. So that would be right here. Oops. And right there. Okay. So our parabola is never going to cross the x-axis. Okay, so what's our answer to this? Our answer is no solution. Where does the parabola cross the x-axis? Nowhere. Therefore, there is no solution to this equation. So sometimes our solution is going to have 2 things, sometimes it'll have 1, and sometimes we'll even get 0. Okay, so a quadratic equation can have 0, 1, or 2 solutions. Explain why. The solutions are the x-intercepts of the graph of the corresponding parabola. Therefore, since the parabola could cross the x-axis, zero, 1, or 2 times, those are the number of solutions. And we saw all possibilities in our last 3 examples. So in number 3, we had 0 solutions. In number 2, we had 1 solution. And back here in number 1 down here, we had 2 solutions. Okay? All right, that concludes page 2. Let's flip it over and see what we have for page 3. On the last page, we have the directions finding zeros. So because the zero of a quadratic function is an x-intercept or x-intercept, so the function's graph, you can use a function's graph to find the zeros of a function. So it's the same thing as before. So we're just practicing graphing and finding where it crosses. And let me remind you why it's the x-intercept. Okay. So we've done finding zeros for linear functions already. So here's a little linear function, 2x plus 4. Okay. And if I wanted to find the zero, remember we said, okay, well, we want to know what x makes this equal to 0. So we could set it equal to 0 and then solve for the x. So we said 2x was negative 4 and x was negative 2. So our 0 was negative 2. So let's graph this line really fast just to see what it looks like. So we put our y-intercept at 4, and our slope is 2, so we go up 2 and over 1. And as we go back this way, we would find out that this graph is going to cross the x-axis at negative 2. And that's because the x-intercept of our graph and the zeros of a function are the same thing. So since we're looking for zeros for a parabola here, our function makes a graph of a parabola, we might have 1 0 or 2 zeros or even no zeros at all. Okay, so let's graph this and find out. First thing we're going to do is find the axis of symmetry, just like before. Okay, so our axis of symmetry is x equals negative b over 2a, which is negative 6 over 2 times 1, for negative 6 divided by 2, which is negative 3. So our axis of symmetry is going to go at negative 3. So this is the axis of symmetry, x equal to negative 3. All right, then we need to find our vertex. So our vertex is negative 3 something. So I plug the negative 3 back in, and we have negative 3 squared plus 6 times negative 3 minus 7. So that's 9 minus 18, which is negative 9, and negative 9 minus 7 is negative 16. So obviously that's not going to fit on our graph if we go by ones. So we have some choices here. I'm going to go by 4s on my graph. So since I'm changing the scale, I'm going to put little 4s next to here. So that's 4, 8, 12, 16, so forth. So as I'm going down, that's negative 3 over, so 1, 2, I need to keep my scale to show that I'm going by ones on the x-axis. So 3 over and 16 down. That's 4, 8, 12, 16 is the 4th line down. Okay. All right, so now we'll make a little table to find our different values until we get the place where it crosses the x-axis. So the first thing I'll do is go 1 to the right of my axis of symmetry, and I'll check negative 2. If I plug negative 2 into my formula, I get 4 minus 12, which is negative 8, and negative 8 minus 7 makes negative 15. So negative 2 makes negative 15. That's 1 up from there, okay? And then I mirrored it over to the other side. And negative 1, I plug negative 1 back into my formula. I get 1 minus 6, which is negative 7. Okay, 1 minus 6, which is negative 5, and negative 5 minus 7 is negative 12. So at negative 1, I get negative 12, and then I'll mirror that over to the other side. So I haven't crossed that x-axis yet, so I'll keep going. 0 is my y-intercept. 0 is negative 7. So at 0, I'm going to go just a little bit above the second line down, and then mirror it over. And then we'll check 1. At 1, we get 1 plus 6, which is 7, and 7 minus 7 is 0. So at 1, we finally find our x-intercept, so we move it over to that side. So here is our parabola. Okay. And the places that it crossed the x-axis were at 1 and at, well, what point is that? That's 1, 2, 3, 4, 5, 6, 7. At 7. Okay, so at 1 and 7. So the zeros of my function (1) and 7. So those are the, 1 and negative 7. So those are my two inputs to my function that will make the answer to the function work out to 0. So let me show you real fast, make sure that works. So we have f of 1, that's 1 squared plus 6 times 1 minus 7. So 1 squared is 1, plus 6 is 7, and 7 minus 7 makes 0. So that works. And if I plug negative 7 into this function, I should also get 0. So negative 7 squared, that's going to be 49, plus 6 times negative 7, that's going to make negative or positive 7, and then subtract 7 more will give me 0. So it did work. So these are the two inputs that make the function have a value of 0. And those are the places where our parabola crosses the x-axis. All right, so one more practice of these. Find the zeros of f of x equals x squared plus x minus 2. So axis of symmetry. This is x equals negative b over 2a. That's negative of 1 over 2 times 1, which is negative 1/2. Okay, so our axis of symmetry is a fraction. That's okay. We just put our axis of symmetry right between 0 and negative 1. All right, now I'll find my vertex. My vertex is going to be negative 1/2 and something, so I got to plug that negative 1/2 back in. So f of negative 0.5 is equal to negative 0.5 squared plus negative 0.5 minus 2. And I'm going to get the calculator for that. So negative 0.5 squared minus 0.5 minus 2 gives me negative 2.25. Okay. So that's a little more than 2 down, 2 1/4 down. Okay. All right, so I'll make my table here, plot some points, x and y. The first one I'm going to do is x equal to 0, and that's easy. That's the c value, so negative 2, no work involved. So that's right there and right there. And then I can move 1 over, so I'll check at 1. If I plug 1 in, I get 1 squared, which is 1, plus 1 more is 2, and minus 2 makes 0. So 1, 0 is my next point, and that's great because that's the place where it crosses the x-axis. So here's my parabola. Okay, and it crosses the x-axis at x equal to 1 and at x equal to negative 2. Okay, so my zeros are 1 and negative 2. Okay, our last one. What is the relationship between the solutions of a quadratic equation, the x-intercepts of the graph of the quadratic equation, and the zeros of a function? Well, this should be pretty apparent by now. They're all the same numbers, okay? So the solutions, we graphed them to find them. We found them by finding the x-intercepts. The x-intercepts, therefore, are the solutions, and the solutions are the x-intercepts. And when we found zeros, we also found out the zeros were the x-intercepts. So therefore, everything is the x-intercept, so they're all the same. They are all the same values. Okay? So if you found the x-intercepts, then you found the solutions, and you found the zeros. They're all the same. All right, I'll see you in class next time. We'll practice more graphing of parabolas, and this time we're doing them to find solutions.